Today we're going to look at analyzing graphs and different characteristics of graphs. The first thing we're going to talk about is the y-intercept. The y-intercept is located on the y-axis, so the vertical axis. Any y-intercept has an x value of 0. Sometimes we're able to look at the graph and visually see the y-intercept. Other times we actually need to solve it algebraically. In order to solve it algebraically, we take x is equal to 0 and we sub it into the equation and then get the output, which is the y value. So looking at the graph below, these continue in both directions. Use the graphs to estimate the y-intercept, then find the value algebraically. So when I'm looking at the graph, I can see that there is a point right here. So my estimate is that the coordinate is 0, 4. But now I'm going to go and solve algebraically. So I'm going to sub x is equal to 0 into the given equation. When I plug in 0 for x on the left-hand side, I need to do the same on the right-hand side. Then I'm going to simplify. 0 cubed is 0, 0 squared is 0, negative 6 times 0 is 0, so I'm just left with 4. So algebraically, my y-intercept is 0, 4. Finding zeros. Zeros are also known as x-intercepts, and they're also known as roots. It's a little bit confusing, but we just use different words just based on the way that the problem is given to us. So if the problem is given to us as a function, then when we solve for x-intercepts, we're really solving for zeros. So an example would be f of x is equal to 2x squared plus 1. If we solve for the x-intercepts, those are really called the zeros. Now, if the problem is given to us as an equation, then the x-intercepts are called roots. So an example of this would be 0 equals 2x squared plus 1. In both cases, we're really finding the coordinates on the x-axis. They're just named different depending on how the problem is given to us. The bottom line is to solve for the zeros, x-intercepts, or roots, we set the function equal to 0 and solve for x. Now let's go and solve the problems below. So if we're going to set the function equal to 0, I'm first going to common factor because I see that I have an x that I can factor out. Then I'm going to factor the trinomial, so I'll use the crisscross method. I'm multiplying 3 times 8, that gives us 24, and then the b value is 10. So I'm looking for numbers that multiply together to get 24 and add together to get negative 10. I take those two numbers of negative 6 and negative 4, and I rewrite the question, but I change the negative 10 to be negative 6 and negative 4. The next step is I'm going to common factor the first two terms, and then I'm going to common factor the second two terms. After I do that, I see that I have now 2 factors in common. So yet again, I have to factor that out. So x minus 2 is common in each, so I'm left with 3x minus 4. Now that I have it all factored, I can find the x-intercepts by taking each parentheses and setting it equal to 0. And now I have 3 different answers: 0, 2, and 4/3. Each are a 0 or x-intercept. In the last question, we're going to do the same thing. We take our function, we set it equal to 0, and we solve. I'm trying to solve for t, so that means to get rid of the square root, I'm going to square both sides. And then to solve for t, I subtract 1 from each side. And divide by 4.